don't miss classes, right? I request you not to miss classes because industry needs deep learning and NLP. We'll cover extensively the deep learning and NLP in a real-time perspective. Okay, so uh, so to understand, or in the process of deep learning, right, we'll use this central tendency and this data distributions, normal distribution kind of thing many times. Okay, machine learning definitely we have to have, and we have it. So what are all going to be covered here is DNN, deep neural network, convolutional neural network, recurrent neural network. RNN is also there, recurrent neural network, right? And then natural language processing using deep learning, and computer vision using deep learning. Okay, so this is this is like we learned all fundamentals so far, and we are going to apply them. Okay, and here the deep learning is inspired by human neurons. How neurons will communicate is each neuron will process a little bit and pass that information to the processed information to the next neuron. The next neuron will process a little more and pass it to the next one. Like that, millions of neurons will interact between themselves. Okay, so I muted Keshwa. So it is inspired by human neurons. There will be millions of neurons communicating between themselves, are transforming knowledge between themselves, right? That's how they think human neurons work. They think scientists doesn't know everything, right? So I hope I think they don't know what exactly is happening inside human mind, and they think like this, and this is the basis for the what you call it as the AI engineers to devise a neural network. It is basically a ensemble model. Okay, let me take a screenshot of this and then start explaining the basic idea of a neural network. It's a very exciting concept to understand. Let me take my pen. I have two problems. One, I don't look into the nodes before I come, and I don't connect my board before I start class. Okay, this is an ensemble model basically. This is a sequential and parallel ensemble model. If I talk about ensemble model, right, what we have seen is a linear regression model, an SVM model, and a random forest model, right? Three models are trained. You passed n number of records. Record 1, record 2, record 3, right? All this data you pass to this one, and this one, all three. When a new record comes in, right, you are passing it to this, and this, and trying to see what the prediction is. Based on the prediction, maybe soft voting or hard voting you are taking and making prediction, right? So here also, this x1, x2, x3 are the data, right? So you think about it as a row vector. Row vector, you remember, right? Each row is represented as a column, right? This is first value, this is second value, third value. Again, second row, third row, fourth row, like that. M number of rows you pass to the network of neurons, we call them as. These are all neurons. Okay, these are all called as neurons. So each neuron is a logistic regression neuron. Just start to begin with, right? I'll take these neurons as logistic regression neurons. These are called as hidden layers, right? There are three layers. layer 1, layer 2, layer 3. What is happening is, if you have 10 here, 5 here, 20 here, 3, 4, 6, 8, 9, 10, like that, right? So these are all x values. This x1, 10, 5 and 20 will go to this logistic regression neuron. The same values will go to this logistic regression neuron also. The same values will go to this logistic regression. The same will go to this. The outcome of the logistic regression neuron is what? The outcome of logistic regression neuron is what? Okay, two questions. One, when I said, right, it is taking the 5, 10, 5 and 20. This neuron is taking 5, 10 and 20. I said logistic regression neuron. When I say logistic regression neuron, what is happening there? What is the equation? What is the hypothesis function of logistic regression?
Sigmoid.
Sigmoid, right? 1 by 1 plus e power minus of theta 0 into 10 plus theta 1 into 5 plus theta 2 into, I think theta 0 is not there. Theta 1, theta 2, theta 3 into 20. Do you agree? Do you agree? Inside this is the equation. Do you agree? I think I should take another color. Do you agree, disagree with this?
Yes, sir, agrees.
Agreed, right? But where is the thetas? These are the thetas. These lines are the thetas, right? There will be random numbers chosen here. So if you take a logistic regression or linear regression and talk about gradient descent algorithm, right? It uses gradient descent. The deep learning uses gradient descent, right? It takes random numbers, right? Maybe it takes 6 here, 8 here, and maybe 4 here, and multiplies and produces some number. What is the outcome here? It is going to be 1 less than, not equal, 1 less than, sigmoid less than, 0 less than, 0 less than, sigmoid less than 1. So a value between 0 and 1 is going to be outputted, this node. This node will also output a value between 0 and 1. This node also, this node also. Again, here, there are values between 0 and 1. There are values between, right, maybe 0 0.2, 0 0.4, 0 0.2, 0 0.3. We are getting different outcomes. Why different outcomes we are getting here?
Different thetas.
Different thetas. Very good, sir. So here in this, for this node, there will be random different thetas. For this node, there will be different random thetas. For this node, there will be different random thetas. When you pass random thetas, this equation's outcome will change. So 0.2, 0.4, 0.2, 0.3. And you are passing these 4 values to first node again. When you are passing again, random thetas will come. Again random thetas. Again random, right? This one will also output a number between 0 and 1, right? 0 0.1, 0 0.5, 0 0.2, 0. Maybe 4, something like that. And again random thetas, right? Random thetas. These are all logistic regression nodes. The outcome, right? So input we passed here. There is y value, right? There is, these are all x's, but there is y value, right? Now there may be y value 0.2, 0. Y value 0, 1, 1, 0, 2, 1, like that. This is y values, right? M y values will be there. This y value is taken here. Okay, this y value is taken here. In a neural network, you define the number of hidden layers. In each layer, how many nodes should be there, right? And then what is the y value? Depending on y value, you choose the output node. This is the output layer and output node. If your y value is a multi-class, right? Multi-class, 0, 1, 5, 9, like that it is there, then you take this as a sigmoid function, a softmax function. Softmax regression classifier. If it is only 0 and 1, right, you take it as logistic regression again. Okay. The output node will change depending on the target variable. And in some cases, right, you may take multiple output nodes also. Okay. We'll talk about multiple output nodes later. But for now, This is the neural network. We call this as neural network. If there is only one hidden layer, then you call it as a shallow neural network. If there are multiple hidden layers like this, then you call it as deep neural network, DNN. The total neural networks, shallow neural network, deep neural network, convolutional neural network, recurrent neural network, everything is called as artificial neural network. In interviews, right, they'll ask you this question to confuse you. What is the difference between artificial neural networks and deep neural network? Deep neural network is a part of artificial neural network. All are artificial neural networks, whether it is shallow or deep or CNN or RNN, whatever. Right? Deep neural network. If you have multiple hidden layers like this, then you call it as deep neural network. Only one hidden layer, right? Input layer, one hidden layer, and output layer. Then you call it as shallow neural network. Any questions here? Okay, I forgot to explain one thing.
So
I
here,
said, yeah.
how the thetas are taken, all this that stuff will be explained later
Yeah,
in
that's
detail,
what
right?
I forgot. That's what I explained.
Okay.
Sorry. So random thetas I said, right? Here in the first iteration for the first record, right? There are random thetas. Now, when you predicted something, right? Maybe you got 0.3. That means it is 0, less than 0.5. So it is 0. The y value is also 0 for first record, right? So there is no adjustment. But for the second record, when you passed, if it predicted maybe 0.2, it predicted 0. Actually is 1. Right? There will be difference between, no, there is an error. Right? When there is an error, these weights should be the mistake, right? If the weights are correctly taken, then the prediction would have happened correctly, right? Weights are the understanding. So what the algorithm, what the neural network is going to do is, in every iteration, it will do a forward propagation. What is forward propagation? Taking the weights and multiplying them and linear combination, and then calculating sigmoid and passing, passing on to the next layer like that. That is forward pass. Backward pass is it will adjust the weights in such a way that the error will be reduced. Okay. In the first iteration, everything is random. In the next, from the next iteration onwards, right? Those random values, random thetas will be adjusted to correct the error or reduce the error. In gradient descent also it is doing the same thing, but it is doing it on one node. Here we are doing it with multiple nodes. Right? We will understand more, right? More about how the weight should be chosen, and is there a control on weights, random weights? And if the algorithm, the network is not choosing the random weights correctly, what will happen? Vanishing and exploding gradients. The algorithm will not work. The neural network will not work. So how to control it? Those all things we'll understand as part of the next the course. Right? There are many things we need to understand. Any other questions here?
Sir, one small clarification, sir. So if you look at, let's say, in the hidden layer, let's take the leftmost column, topmost LR. The output of that is nothing but Y from that LR, which is going to, let's say, the next layer 3 LRs or 4 LRs. Correct, sir?
Give me 1 second, sir. Let me wipe this out a little bit. Maybe. Yeah, now it's a bit clear. So which one you are talking about?
In the hidden layers, there are 3 columns. Is that correct?
This one, and this one, right?
Correct. That is correct.
Right. These 3 hidden layers, yeah.
Yeah. So I'm referring to the first hidden layer, the leftmost. So from there, on the top LR is what I'm referring to, topmost, that one. Yeah. So that is giving output to the next layer 4 LRs. It is giving output, correct?
Yeah, it is. This green line is the output from this LR going into all the 4 nodes.
Yeah, sure. So that output is nothing but the Y of the top LR of leftmost.
Y cap.
Yeah. Y cap, sorry. Yeah, Y cap. And then because the Y cap value is same value is going into 4 LRs.
Yes, indeed.
And then like that, many y caps are coming from many LRs into the, let's say, second layer.
Yes, sir.
So they will become basically X for each of the
Yes, sir.
second layer LR.
Yes,
They will
sir.
become different X's for
Yes,
second
sir.
layer LR.
Yes,
And
sir.
again, second layer LR will predict again y cap uh, like that. Is that
Yes.
high level? Is this what is happening here, sir?
Yes, sir. Yes, sir. Instead of taking, in machine learning, you are using only one logistic regression. You are passing these values, and then you are calculating y cap here itself, and calculating error here itself, and then trying to adjust the weights, right, to these three weights,
Right.
right? But in deep learning, right, you have magnified this into a big network, not just one logistic regression. You are using, if you want, you can use 1,000 logistic regressions, maybe million logistic regressions. Right? You can make the model as complex as possible. When the model is weak, right, in understanding, you can make the model as complex as possible.
Yeah, I think that is not my point, sir. My point is just for my understanding, one layer's y value is going and becoming x for the next layer.
Yes, sir.
And and then again, based on those multiple x's coming to the next layer,
Yes, sir.
thetas will be calculated, and again y cap will be in the second layer will be calculated, and it goes on. This is what
Yes.
is happening.
Yes, sir.
Just wanted to confirm from this.
Yes, and that's correct. Your understanding is absolutely correct.
Okay.
So that is neural.
So the inputs are taken only for the first layer.
The inputs will go to the first layer only, and from next time onwards, it is all processed data. These are like brain neurons.
Predictions of first layer will be taken as input for the second layer.
Yes, and yes. We should not be saying predictions there. There are intermediate values. Ultimate prediction is, as a team, they are actually finding out, and now this is the last output node is going to give. These are all helping the output node to make predictions, and the cost function is actually looking out to see whether the prediction is going in the right direction or not. The neural network is going in the right direction or not. The weights are actually getting adjusted in the right direction or not.
Sir, here output layer, like it will give the three results, sir, because see, three logistic regressions are pointing to one, right?
No, that's
So,
what Girigar was actually saying, right? You pass the outcome of these three as access to this one, and ultimately it is going to give 1 by 1 plus e power minus of linear combination. There is a weight here, there is a weight here, there is a weight here. It multiplies this weight with this value, this outcome. It multiplies this weight with this outcome, multiplies this weight with this outcome, combines them, linear combination, and puts it into a formula 1 by 1 plus e power minus of that combination. That's going to give you one
sigmoid
number.
function. Okay. Now sigmoid function applies and it will give that final output, sir.
Yes, and yes.
Okay.
If you have multi-class classification, then softmax you will use, because linear regression, logistic regression can give you either 0 or 1, but softmax can give you one number out of 10, right, or one number out of 20.
Yes, sir.
And if you have multi-label and multi-output also, you can handle it with deep learning. I'll talk about that later. First we understand this and go a little forward. Then I'll talk about multi-output and multi-label classification. And in the multi-output, multi-label, we used only KNN algorithm there in machine learning, right? That algorithm is not that powerful, and you cannot use it with huge volume of data. But here, you can actually use it on a huge volume of data also. Without deep learning, you cannot do anything in AI. That's the taken for granted statement. If somebody doesn't know deep learning and NLP, they are not useful in any project. Okay. So I'll stop it here, right? You understood what is neural network. Tomorrow I'll show you the advantage of using neural network. Advantage of why neural network? How can it actually do a very complex nonlinear decision boundaries when compared to machine learning? With a simple example, this is from Andrew Ng's notes, and then we'll see, right, the sigmoid neuron, how exactly the back propagation is happening. We already have seen it. right? Briefly, I'll just, in 15-20 minutes, I'll explain that. And then neural network architecture and how exactly those neuron calculations are happening, and how should you actually understand how many weights are being induced into the neural network, and we should be aware of the total size of the matrices and all, to see whether our hardware will support the network or not, the design network or not. That stuff we'll see tomorrow. Okay. So that's it for today.
Sir, are we covering GANs also?